I, Kosha Mehta, welcome you all to this lecture series on Agricultural Market Intelligence and eNAM, organized by Center for Agricultural Market Intelligence under Nahib Kas Anand Agricultural University. Before forging ahead, may I request Dr. Pundi to felicitate Dr. Kumar. May I request Dr. Snehal Mishra to welcome Surabhi ma'am. Next up, I would like to request Dr. Ganga Devi to felicitate Dr. Pundi. To begin ahead, may I request Dr. Pundi, Dean IABMI and PI Nahib Kas to present his welcome address.
Thank you, Kosha. Actually, before I say a few words today, and you all know about this program's today's lecture series, and in that lecture series, you all know that we will be having 4 very important lectures by our guest speaker, and guest speaker is a very formal term for us, for me particularly, Dr. Kumar. So today, 2 lectures, we'll have 2 lectures today, and 2 lectures will be after tomorrow on 7th. So this occasion, sir, I don't have words, but I welcome you here with simple words, not saying suffix and prefix here. As our guest speaker, very esteemed person in academic fraternities, and something I think brief we have here. I also know something very well about some, but I will say a few things. Sir, your contribution in academic world, particularly focusing attention on this very complex issues, price forecast, demand supplies, number of issues in maybe the irrigation areas or whatnot in dairy areas. So with focusing attention on econometric analysis, production function analysis has been immense. And we see this thing all when we read the literature, and it's spanning over more than 40 years, and maybe some papers are, sir, before 80s. I don't know, sir. Some papers we see before 80. So, though being an agriculture economist and basically statisticians, your contribution in this area is immense. We don't have words, we can see and we can write many things. If somebody is interested, they can see the reports, maybe particularly in IRA library. And many students have earned their degrees, PhD, MSc under your guidance. So today we have this maybe the opportunity. We are really very fortunate to have with us and to accept our invitation to deliver these 4 lectures. And these 4 lectures are not simply the lectures, sir. Basic objectives are under Nahib Kas, National Agriculture Heritage Mission is of Government of India through ISAC and World Bank, how to improve the quality of research and teaching at university level. This is the purpose. And when we say the quality of research, it means the technical issues, how to address the technical issues so that the MSc students, PhD students, and faculty members could design good projects, could have the understanding of these issues or technical issues. So this is very, very important. And in view of that, we are requesting many guest speakers here. Number of guest speakers already have been here before, sir. But sir is coming first time. For the last 1.5 years, specifically, though Dr. Surabhi is here with us, some of you who are associated with the Nahib Kas, they know. But we requested a long time back. But because of these pandemic situations, we could not force you. So we were also reluctant. Though we have received many speakers, more than 68 programs have been conducted under this 9 projects, including some programs on methodological issues. And some key speakers taken from maybe Dr. Joshi, Dr. Ramesh Chand, or Dr. Vijaypal Sharma. A number of good, eminent speakers have been here. But we always wanted some speakers like you, who we call, maybe certainly, I don't know, sir, you know or not, Vision Pitama in econometrics. Many times we say this thing, but that is separate thing, sir. So these are 2 things from my side. And sir, today we have received till yesterday 700 people have registered for that. Maybe we expect they will be joining this online around 400 or so, but it will depend on lecture wise. In some lecture, some come, in other lecture they will come, but they have, and here some 75 or so are there. Some will be joining in the next year lectures. And these 4 lectures on total factor productivity, demand and supply, and food security aspects, we have chosen these things based on our understanding, literature review, and in consultation of some experts. Dear students, most of the students, this program is centric to, as you know, PG students. That is only PG students and PhD students and faculty members. So normally in this program we don't invite UG students. So sir, we got few things from our side, and you like from your side, the way you are known as the best teacher and best researcher par excellence in these 2 areas, in these 4 lectures. With these things, sir, once again I welcome you here, and it is our blessing to have you with us. I also welcome Dr. Shurbi. Dr. Surbi is even, I think somebody was saying, okay, Surbi ma'am. Surbi is more than that. Dr. Surbi. We may call you sometime Surbi ma'am, but she is a known academician also. So Dr. Surbi, I welcome you also here. You will be staying with us a few more days because you are associated with us. And I also welcome my other colleagues, Dr. Kanda Devi, Dr. Shani Mishra, Dr. Shakti, and all the students, PG students who are here. Shall will be joining at this moment. And these are few things from my side. Thank you.
Indeed, everybody is waiting for the session to begin. Although I would like to introduce our guest speaker, Dr. Prabhupad Kumar. Sir is former professor of agricultural economics at Indian Agricultural Research Institute, New Delhi, and has been conducting research for almost 45 years. He has made significant contributions to different sectors of agriculture, including water management, livestock, crops, and fisheries, and has written extensively in the areas of total sector productivity, sustainability issues, demand supply projections for food commodities, price policies, and nutritional security. Dr. Kumar has developed a number of econometric models for crops, livestock, and fisheries. His research on total factor productivity and food demand projections are used and acknowledged at national and international level. Sir has been humble enough to supply such short introduction, but if I were to say that he, along with Dr. Surbi Mittal, has contributed revolutionary in the researcher fraternity, that too would be an understatement, I think. On that note, I would like to invite Dr. Kumar and take over for the session on total factor productivity estimations and returns to research investment in India. Please have a big round of applause for Sir.
Sir, if you feel comfortable, we can do this anyway. It's up to you, sir. No, yes. For me, everything. But we would like you here, please. Yes. But because this is live, sir, so this is what for this one? This one. Otherwise, sir, will be around, right?
So, I think Professor Kumar has already given a big introduction for the Dhamma. That's not true. In the world, if you read Dr. Nagar, yes, Krishna, they have done very outstanding work. And we are just copying them and using the econometrics just to convert to policy research. So what we are doing, we are not doing any research in econometrics. We are using the tools of econometrics which can be used for policy analysis. That was our contribution to convert the theory into the practical, so that can be used for development, food security, and so technology. So my contribution was to convert the everything into the elasticities. Either you call demand elasticities, either you call supply elasticities, you call income elasticity, you call cost of production elasticity, you call drought elasticity. So, and then I implemented those elasticities in all the areas of agriculture, in the water management, construction of field channels, its implication in Odisha at Hirakud land, where we chosen two crops, maize and groundnut, in 1966, and they are top in India. So these two crops for Odisha. And once we started those crops, and farmers were not knowing that how to use groundnut because they don't have the processing unit. How to use maize, they don't know how to make maize flour, maize atta. So once the crop came up, we visited the villages. They came like fighting with us. What to do with this maize? What to do with groundnut? Because they cannot eat, they cannot market, and so then we realized our mistake that we never thought about marketing. We had never thought about market intelligence. That what will happen with these two crops. Then we contacted the Punjab government. We tried to procure entire maize to the Punjab. We contacted the Gujarat government, and they're taking care of ground process. Then we realized as economists and as a technologist, we should not implement any crops in any place until we study first marketing aspects. And that is why the marketing intelligence is a very important subject, which if you want to implement the policies, if you want to increase the production, if you want to do anything on those lines, we cannot succeed. Once we giving the market to Odisha government, and they started the maize processing that has lifted as a feed to Punjab and other places, and groundnut, Gujarat business people eat over there. They stalled the processing unit of groundnut. Then farmers were very happy. They made a lot of money. And then today, on the Indian map, for groundnut and maize, the top number one. And so that is why my saying, until we have the market, until we know market intelligence, nothing can be success, and we cannot uplift it with the farmers' income. And for that purpose, I have chosen few topics here. The total factor productivity, because many times in the lectures by all our DE and everyone, White House, they say, why not increase the total factor productivity? As the economists, we start thinking partial factor productivity. We start thinking marginal value product, marginal physical product in that term. Then people say, why this word is total factor productivity. So here I'm here just to clarify what is the total factor productivity concept and how we can use it, measuring the returns to investment on research, on extension, on education, on infrastructure and market and so. So these are the things we can use to that. So let's see the concept first. We heard the name of technological change, right? The concept and estimation method. So what we do, we estimate the TFP index for, and then we find the sources of TFP growth. Then we go returns to research investment. This is the way I'll just my lecture will follow. Yes. Now, let's think about this. Okay.
By the big pointer.
Now let's understand what is the total factor production. You know all production function. We say production is a function of inputs, right? We know this part only. Production is a function of input. As the input increase, output increase. Now, each input have two components. Let's say X1 is seed. We say this crop requires 10 kg of seed per hectare. 10 kg is a physical quantity of seed. Now, question comes, which variety? Which variety of seed? Is it a local variety or high-yielding variety or hybrid and so on. The variety is a technology. So each input had two phases. One physical quantity and technology. And the variety is technology. Technology is developed by research. By breeder develop the varieties. And it is a knowledge-based inputs. By conducting research, by making investment on research, and so, and by conducting the trials, and so we develop a variety. And development of variety may take even 10 years, 12 years, 5 years, and so. So let's say X1 is seed, and it has two parts. X1 multiplied by T1. X1 is a physical quantity of seed, and T1 is the technology associated with seed. And technology is knowledge-based input, derived from the research. Similarly, let's say X2 is fertilizer. We say you apply 50 kg of fertilizer per hectare. Then question comes, what combination of NPK we should use 50 kg? When we should apply the fertilizer? How to apply the fertilizer? In what proportion NPK to be used? When to be used? How to be used? This knowledge is the knowledge-based inputs. It is a knowledge-based inputs. So you say we apply 50 kg of fertilizer, but NPK to be in the ratio of 3 to 1. We say you apply 1/3 of fertilizer at the time of sowing, 1/3 you apply at the time of flowering, 1/3 you apply at the time of seed setting. So from where you are getting this knowledge, what combination NPK to be used, when to be used, how to be used? It is done by agronomical trials. They conduct a lot of research and establish that which combination of NPK give the maximum output. When to apply the fertilizer so that production yield is high. And so this is the technology which we associated with fertilizer. Then we have a technology irrigation. You say you do 3 irrigations. Question comes whether we should use the flood irrigation, whether we should use the spring irrigation, whether we use the drip irrigation, and whether we should give at what stages we should give the irrigation. So this part is technology based on our experiments. So water is a physical input, and how to use the water is a technology. So if you call number of factors, each factor has one component of technology. That is why I say your output is a function of x1 T1, x2 T2, x3 T3. Then we say total impact, seed technology impact, fertilizer technology impact, irrigation technology impact, infrastructure impact, market impact. This is the total technology. That is the capital T. That is why it is called total factor productivity. That we are measuring the impact of all the inputs as one technology. We cannot separate out. Seed, fertilizer, and so all are to be measured by technology. That is why the output is a function of physical inputs and technology. Once you write into growth form, then we can write this model that output growth is equal to input growth plus technology growth. So technology growth will be equal to output growth minus input growth. And this, because they are in log term, you say TFP index is equal to output index divided by input index. So in the books, you find only one definition: total factor productivity, nothing but is the ratio of output index divided by input index. Then somebody asked, then why you call it technology? You cannot explain by the last term. But if you want to explain, you have to explain that the output is a function of physical inputs and physical input associated, each input associated with physical quantity and technology, and therefore the impact of all the technology associated for each input is the total factor productivity, and this we can measure by constructing the output index and the input index, and that is why this is the concept of total factor productivity. And if you prove, just this. Now, if you say Q is equal to X and T, what is it? You see isopath. On y-axis, you take input. On x-axis, you take technology. On z-axis, you take output. Then you draw the technology isopath, right? You understand the isopath. So if you increase the technology, you can reduce the use of inputs to produce same level of output. If you want to increase the use of inputs with less technology, you can produce the same level of output. So what is happening here? On this, so this isopath, we have to look on this. It means if the contribution of technology is higher, then we can produce with less inputs. And if we produce with less inputs, our cost of production will be low, because farmers does not pay for T, farmers pay for X. And once T is high, X is low. If X is low, cost of production is low. If cost of production low, the profitability is high. So agriculture system is sustainable. If we produce output with high level of inputs, less technology, the cost of production is high. When cost of production high, if not supported by high prices, income is low. So agriculture will not be sustainable. We say agriculture is unsustainable. To make the agriculture sustainable, we have to increase the contribution of technology in production, and that is why the importance comes that why not you produce the output based on knowledge-based inputs. And what is knowledge-based inputs? Your variety, your method of fertilization, method of irrigation, infrastructure, and so. And this input will come by knowledge, and to generate this knowledge, we need the investment on research. We need the investment on extension to increase the adoption. Because without adoption, farmers cannot adopt, farmer cannot use the technology of high variety seeds, and therefore this concept comes. That is why once you talk about this sustainability concept, just keep in mind the isoquant between input and technology, and then say if you want to increase the output, you have to increase the input also, you have to increase the technology also, and then try to see how we can produce based on technology as much as possible and so. Yes. Now, so we have many approaches, parametric approach and accounting approach. If we have the cross-section data, then we go parametric approach. If we have the time series data, we go accounting approach. Because technology is a dynamic process. It is not a stable. So therefore, we need the time series information, and the technology we developed 1950 may be different in 1960, may be different in 1970, and therefore it is a time series framework. And for that, we need the accounting approach. Otherwise, we use the parametric approach, which is done by many in the classroom. So in the parametric approach, we say production is a function of X and T. X is input and T is technology. That is why in simple terms, we say T is a time framework, because the time is also a technology moving. We use the cost function. Cost is a function of output and technology. So if we differentiate with the output or cost with respect to T, we say this is the measurement of technology. This is the based on cross-section data we collect, and then we try to use it production function approach. Yes. Once you go there, then you fit the production function for improved technology, for local technology, decompose the production function, and then find what is the contribution of technology, what is the contribution of additional use of inputs. And by doing so, we decompose in two parts. Output is equal to technology component and the input component. Next. So this is a graphic presentation. We have the first line is the local technology. Yeah, this is the local technology. Then we have the improved technology. Let's say X1 is the use of inputs. Once we know the X1 by local technology, we are able to produce up to Y1. But as soon as the improved technology comes, we are able to produce CY1 additional. This is the technology impact. But as soon as new technology comes, absorption of input also increases. And as a result of that, we go up to Y. And this section adding to production as a result of inputs, and this is adding as a result of technology. So Y1 C is a yield gain due to improved technology, and CY is yield gain due to additional inputs, right? And this you might be in all undergraduate classes, every classroom is taught. Now next. So we fit the production function for local varieties. We fit the production function for improved varieties. We decompose this by Visalia model that change in yield is equal to change in technology, this section, and this section is the addition. So change in yield is equal to change in technology, improve its chain technology, and this is the key. And that way, we can estimate using the cross-section data, what this component we estimate. Let's say this gain is 30%, and out of that 10% as a result of technology, and 20% as a result of addition use of inputs. So this way we can go. Now, another approach is the consumer surplus approach. So there we estimate it is widely used for evaluating the impact of technology on the economic welfare of the household. This methodology also been covered in all undergraduate classes and college classes, and we estimate the consumer surplus, we estimate the producer surplus, because this is technology, local, this is the improved technology with demand, this section we estimate the consumer gain. This section we estimate the producer gain, and the total gain is the sum of these two. So that is the total benefits of it. And then we try to estimate. Here we need the demand elasticity, we need the supply elasticities, we increase how the ISOPAN can shift as a result of improved technology. We have change in consumer surplus, change in producer surplus, and total surplus. And this is the benefits from technology, and we do the impact assessment. This also done through these are the two parametric approach by which we can estimate, use the cross-section data. But most preferably, we require to use the time series data, and that is the most important one to estimate the technology, to estimate the total factor. So, okay, yes. Now we have second approach, the accounting approach. Here we use the Devashiya practice index. We consider the input index, we consider the output index. Once two indexes are available, we divide them, we get the KP. So this looks very simple. So now important part is how to construct the output index and input index. And if these two we can construct, we can estimate the total factor productivity. Now, try to understand if we what is the concept now, how to get the yield production. You multiply area and yield, you get the production. This is the model being used before the total factor productivity concept. You have the area, multiply by yield, you get the production. You have area growth, production growth, you add up, you get the area growth and yield growth, you add up these two, you get the production. But once I explain, your output is a function of x and t. So this is my output. This section is x, this section is t. So this section is total factor productivity. This section is the input contribution to output. So output has two parts now. This is total output, this is input, this is TF. So output growth is equal to input growth and TF growth. And how to get the input growth? It is done by input price, output price, technology, infrastructure, and so these are the factors which influence the use of input. This factor influences the demand for inputs. If price is low, if there is a subsidy on fertilizer, farmers use higher level of input fertilizer. If there is a good infrastructure of canal irrigation, good and low water table, then people like to use this input much more. And as a result of this inputs, output will be high. But this input is generated by knowledge-based inputs. And what is knowledge-based input? Research. Adoption means with extension. Education. If education good, farmers will adopt faster. So extension contribution in infrastructure, nature of natural resources, the quality of soil, fertility, and so health of the nature resources. These are the factors contributing the TFP. So they are the sources of TFP. Once we want to know what are the sources, then we try to regress total factor productivity with respect to research investment, extension investment, education investment, infrastructure, means market, and so roads and electrification, and so, and then we come here. So we regress this factor as a function. What data we require? We require very simple data to construct the TFP. We need the output. Let's say there are 10 commodities, 10 crops. We need the production data. We need the price data of these commodities. We need the input data. How much fertilizer, how much irrigation, how much seed, and their prices. Only 4 types of quantity and pricing data we require to estimate the TFP. So this data is available with us by Director Economic Studies also published input survey and so many data. We can get this data. You can cost of production data. You can use. There we get production data, price data, input data, and so. So this is the very little requirement of this. Yes. Now this is the same again. I just said this is the model, and we want to estimate this. Yes. So how to consider the output index? Your output index, output index in period T divided by output index in period T is equal to a product multiplication Qj minus 1 power Rj plus Rjt plus Rjt minus 1 raised power half. Something wrong.
Online cards.
Okay. Now, input index of the Now, what is R? R is the share of one crop into total crop. Let's say there are 5 crops. And one crop is wheat, and this value is 20. We say 20% wheat contribution in all the 5 crops. Right? And what is Q? Quantity of wheat in period T, quantity of wheat in period T minus 1. And J is the wheat. J2 rice, J3 any other crop. And R is the revenue shares. Here the inputs, let's say fertilizer. Fertilizer in the IF crop, fertilizer in the this is also one year left, and this is the share of one first input in all the inputs. There's a total cost is 100 rupees, fertilizer is used 20 rupees, the share is 0.2 of fertilizer. And so we get the output index here, we get the input index here. Now, but I want to know this TOI. I don't want this. So what will do? I will do this equal to this value multiply this. Right? Then you substitute this value for the one period lag. So you get the second term. If you get another term, you get three terms and 4 terms. Like there are 3 crops. So we get 3 terms like this. One term, then another one term, another one term. That is why I just put a 5. 5 is the new product. Similarly, on input side. Okay, we'll understand more this once we go on Excel sheet. Let's see further. So our model looks like this. The output index is equal to output index in period 1, period 2, period t minus 1. Let's say the 20 years data. So 1, 2, 3, and then 19. Okay, 1 year will disappear because of lag. Similarly, we get the input index here. So what happening in most of the researchers are using the first model, previous selection, and that is a wrong analysis. 99% cases I found wrong analysis because they are not using this step. Now, they are assuming this 100, right? And they are assuming that this is the index, and then dividing this by this, and they get the wrong result. And therefore, there is a need to use the second step chain method, this one. Okay. Until you do this, you cannot compute TFP correctly. That you are wrong. And then, so we get like this some data. TFP on rice. Yes. We also get the output growth, input growth, output growth. Difference is to we get the TFP growth. Output growth, the input growth, output growth, and TFP. That is why in the box I just say output minus input, and then upper portion yellow or the TFP. So this way we this is the old data. Now this is based on the number of districts we can work out what is the TFP. Within one district there will be 20 crops, another district will be 30 crops. We get like this, upper density, lower density, and so. And this here also in the literature I put in one paper. So there you can read it, and then I classified all the districts which are sustainable, which are less sustainable, and so. And that's a good paper. So just like your input growth, output growth, and TFP growth of Indo-Galactic plane. And all the this. Now, I also given in the literature the policy report published by NCAP 25. Myself and Ramesh, we did it, and then we computed the TFP growth for rice, and then we kept the positive real cost of production minus. It means as the TFP increase, real cost of production decline, cost of production decline, profit increase, and we are more sustainable to agriculture. Wheat 1.92, maize 1.39, jawar, bajra, barley. This way we work out the TFP growth, and this is the RSCP growth, and this is the way we get the TFP growth, we get TFP growth. So now we like to look the sources. If you regress this series, because there we get a full series of 20 years. The 20 years we will work out on research, so extension, education, this variable. We fit a production function from regression function. From TFP is a function of this factor. So we say TFP is a function of research, extension, market, balance use of fertilizers, sources of water, rural literacy, climatic factors, and so on. Then the coefficient of research, that is the elasticity of research store, multiply value of output associated with TFP. How much TFP contributing to output? Let's say output contributing TFP by 20%. That's the value of output with and then divide by research store. So by this way we work out expected value of marginal part. So from there we use this elasticity, research elasticity. And then we say value output means if TFP is 30, output input is 70. So 30% output contributed by TFP. You multiply by price, divide by research stocks, you get a factor. That factor you multiply. Then this benefits. Once you develop a variety, it takes few years for research to go to the field. Let's say it takes 5 years go to field. After the 5 years, the adoption will be very slow. Let's say full adoption is taking place in 10 years. So first year maybe 0.1, second year adoption may be 20%, third year maybe 30%, 40%, 50, 60. After reaching the ceiling, continuously few years, 9, 10 years remain same. Then the depreciation of technology. Technology contribution start declining, 0.9, 0.8, 0.7, 0.3, 0.4. So that is why we say benefits will be this, and this. And then start declining. After constant, they start declining. So we get a benefit cost analysis, you get a 2 series. One is cost series, one get the benefit series. And from there, you work out the benefit cost ratio. You work out the internal rate of return and so. And then internal rate of return is the returns to research investment. Now, we understand once we go to actions. Yes. So, if the expected value of margin product 2.2, internal rate of return is 29%. So, price we get 29%, return to investment on rice research. For wheat, 38%. For maize, 28%. Jawar, 13%. Return to investment on maize. 31% for bajra, 34% gram, 18% groundnut, rapeseed mustard percentage. So we can work out the return to investment on research for different crops. Once we estimated the TFP, we estimate the sources of growth, we estimated the expected value of margin product, then only we are able to get this. So let's say we had 9 crop total value base, their contribution is 41%. So if we assume this is a sample, then total contribution research to crop sector is 3748 lakh crore, and then investments on research is so much. We get the return to investment to agriculture sector is 33%. Initial period returns will be higher, later period will be low. As we move with that, the contribution of TFP in total output keep declining, and so returns also comes. And then we need more advanced research so that the TFP can be maintained and systems will remain sustainable. So let's spend 20 minutes on that. So we go, yeah. So we understood this part. Okay, it is just for revision. It is just for revision. So we have this is the concept is clear. Okay, this concept is clear that we have to decompose output, input, and technology we are estimating this formula. Second one, we require this kind of data, quantity, price of input and output, but we have to use this formula in the Excel sheet. Okay, we have to compute for one commodity, second commodity, third commodity, nth commodity, then multiply all of them. Similarly, for all the inputs, we have to do. Okay, this thing we have to build in Excel. Now next, then we have to follow this one chain method. Then we have to compute the TFP. So now we come to the Excel and crop sector. No, Excel. Okay. Last couple. Let's go to the first side. A. Just go this side. Okay. So let's say this is the CSO data. We have the this is what it is.
Sheet PFP index for the full name.
First is
PFP index here.
yeah. Oh, let's no. Oh, this is okay. I'll be here. Anyway, I can see. I can see.
One sentence.
Okay. Hello. So this is the just go to top, only top, keep it there, and then go this side.
Consideration.
No, first one.
CSO 204.
Yeah.
Yes.
Yeah. Okay. Now, so you have the years, you have the data on agriculture output, you have the livestock, right? For simplicity, let's say two items, agriculture and livestock. I say you have to work out the JT minus 1. So this is the R. What is the R? Share of agriculture in total output. You add up these two, you divide this by gross, you get this. 83% is the agriculture share. Livestock share is 16%. Okay, you compute this values. So this is your Q in the formula. This is your R. This is your Q1. This is your Q2. This is your R1 and R2. So you put the cursor here. Here, just put a cursor and see the formula. Okay. What is that formula? Formula is this one, this divided by this. Your third divided by this, right? QT divided by QT minus 1. So you get this value. Oh, this one. Yeah.
Output product is a multiplication.
Oh, this one, this
First
one.
see the
Yeah. First you see this, right? How will I go? I got this. This value divided by this value, right? This value divided by this value, then power this plus this and 2. This one. Okay, you apply this formula. Similarly, you apply this formula here also. Now, this column. Okay, this and this. Then you multiply this 2, which I wrote 5. You get this value, right? Now go for C. There are so many seeds inputs are there. This one. You have a lot of inputs here. Seed, fertilizer, and so. Just go ahead. This is all data. Then you work out the share of each input, right? But how much contribution of seed, how much fertilizer, how much irrigation, and so. You go there. Then you apply that formula, xt divided by xt minus 1, power st plus st minus 1 by 2. Then this is the formula. Okay, you apply this formula here also. This formula. Go for third input, fourth input, fifth input, sixth input, 7 inputs. Go ahead, and then you work out the product. This one, right? You whatever the columns are there, you multiply all of them. You get this values. Then you work out index. This is 1, and then you go this. So what is this column? This column is the your input index divided by tier period and so, which I say normally people live here, scientists live here, but that is wrong. We should go this step further, one step. You multiply this to this, get one, multiply these three columns, three rows, then write down, or you multiply this with this, write down here, multiply this to this, write down here, multiply this to this, write down here, or you multiply the first two, then first three, first four, first 5 lines, and keep writing over here. So this is the chain index of inputs, right? Top. Now this is the output. Okay. Then we get the output, same output here, this one, and then we get the output chain index. You divide these two, we get the TFP index, right? Once you get the TFP index, you work out the growth of inputs, you work out the growth of output, then difference of that, or you can work out the growth of TFP. Bottom out. Bottom. Just like this, right? You get the TFP index, 2.1G. So if you use this template, you can compute very easily once you know your input.
Input share, agriculture plus livestock, total
No.
share, agriculture.
Yeah,
Total is
total.
some input के total में फिर particular
Input
Yeah.
per share.
What is share of each?
Cell number ये share calculation दिखाने देते हैं. So, agriculture plus livestock, agriculture divided by the total of agriculture and livestock.
This one,
Share.
83%
For each year.
out of this,
Share
83%
for each year. For each
of
year.
agriculture, and this is the share of livestock, 16%.
What is the unit for agriculture and livestock? Unit.
Here, this is in percentage, and this may be in crores, in CS.
Monetary terms.
Or you can do one thing also. You can construct an index also here and then do the same calculation. But for that, you have to work out this in separately. So for this,
Suppose here the agriculture as a whole we consider the data. So for inputs means suppose in agriculture there are many crops are there, na?
it is annual data,
Annual data for all the agricultural crops.
all the crops.
All the crops.
CSO give this in this format.
Yeah. And for input also means the input data is combined for all the crops.
All the crops.
Suppose we want to go for a particular crop, so instead of this, we will consider the one crop data.
Yes. I think I will give another template.
Example
So
of one.
now you go, once you construct this index. Any question?
Go back to the same sheet.
Any-
Share for
I want to show research investment. The investment on education, so that value will be there. That value will be there. It is a function of investment on research, investment on extension, investment on education, investment on infrastructure, and so on. So we create this regression. Each coefficient is an elasticity. And I've given a report, policy paper 25. Yes, how to get this coefficient. So let's come to the returns to investment of research. Yeah, last. Let's say you go to the now TFP, okay? So your part is, and you go to the, you regress it, you go to the expected value of marginal research. And what TFP is there. So next. Yes. Okay, then listen this carefully. Please. Don't talk to each other, otherwise you speak. Let's say these are the number of years. What I said, you estimate the returns to investment on research. Once we start research, product comes after 3 years, 5 years, 10 years, 15 years. So here your factor is 0, 0, 0, 5 years. Then I said your returns will be 0.1% of total. This is the marginal value product, 4.1. How I got it? The elasticity of research multiplied contribution of output by TFP divided by research stock, the formula which I gave. So for that, I got 4.1. So you write down everywhere 4.1. Now, if I invest 1 rupee, I get a return 4.1. I get 4 rupees return by investing 1 rupee. Now, this investment is distributed over 20 years. 5 years, no research, no output, only cost. Then again, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.9. This is by assumption. You may also break up in 10 years, or you may say, oh, we cannot achieve more than 40% adoption. So you start depreciating the technology, right? Then you multiply this to this is the gain. If you multiply this, and then here you go for 9 years constant. We go first, we go 0, we go the adoptions, we go fixed, and then we start depreciation. So here is the depreciation. So you multiply this to this, we get the returns, okay? You get the cost series, you get the return series. Once you get the return series, you subtract this to this is -1, and then this is the return series, okay? From there, you work out the IRR last, this formula. You know, this is IRR, there is a formula, this one. And then you work out the IRR. Correct? So this is the returns to investment to research, 39%. So what we have to do, we get the input data, we get the input price, we get output data, output price, we construct the output index, we construct the input index, we construct the TFP index, we work out the regression on TFP, on research and other factors. We work out the contribution elasticity of TFP with respect to research. Then how much TFP contributing to output, at what cost of research. So we work out the marginal value product of research. For marginal value of product means if we invest 1 rupee, we get 4 rupees returns. Now the returns are distributed over years. We build a time series, post and time series on this, and then we work out the IRR. So same way we work out for all the crops and so. So and there is another example which I give on for fisheries scientists. And there is a computation of fisheries. So, so for fisheries, let's say we have two inputs, labor and diesel. Because marine fish both goes, and what is the expenditure? The labor and diesel. And they catch number of varieties of fishes. Let's say there are 9 varieties of fish. In previous example, there were 2 outputs, 9 or 10 inputs. Here we have 2 inputs and 9 outputs. And there, same formula you apply here, and then you can study it, and then you get the share of first variety, share of second species, third species, and so you get the share of first input, second input further, and then you work out the index, you work out the product of index, you get product, you get the chain index, and then you work out the EFP index. So same way you work out the, once you have the data, why you need the price data? Because we have to compute the share of each output, each input, right? And that is why we need the, otherwise this can be in physical terms, anything. The production can be in any terms, or they can be value terms, they can be quantity. And so we get it. Then you apply a formula by just like log y is equal to alpha plus beta t. That way also you can compute using the integration method, and then we get the TFP index, this one, output index and TFP index, 0.36. This also you can use it. So in the literature, so any question here? Just if you keep the theory and then template, you will be able to understand. We spend few minutes studying independently. You will be able to catch how we are inbuilt the formula to access it. Now, so I have given some literature over here. Any question? Yes, I know.
Yes, sir. Sources of the total factor productivity, like extension, research, and market infrastructure. So how we consider the data about this? Suppose agricultural many varieties for rice, for example, rice. So how we take the data for rice for
Yeah.
research, means how to estimate the investment on the research.
Just like if you want to study the returns investment research of A, so you have to work out how much money being spent on by the university from very beginning. Some money will be on infrastructure, building, then fixed kind of expenditure that you consider, take a depreciation on that one component. Another component
Money
is
for means I think it's the common for all the crops. Suppose I want to estimate the
Yeah,
FTP
you
for
have
the
to-
rice only.
yeah, you have to do the number of scientists you have, and there are 10 kind of research. Then based on their salaries, you classify them. You have to disaggregate how much money being spent on research for rice. Number of scientists associated with rice research, right? And what is their contingencies and the expenditure. Once you have the entire source, you work out on that. So that way you have to separate out, depending with your best knowledge and number, and major part is number of personnel working on that and their savings, right? And how year-wise they are going. So that way we, and then stop.
And sir, there are many varieties are
Then-
also there. Suppose
That's right. No,
yeah.
then is a further classification. Whether you want to do variety wise. If you want to do the variety wise, the best approach is the parametric approach, production function approach. first variety versus second variety. Then you have the data of inputs also by variety wise. Right? But if you want this total factor productivity is give the TFP for all aggregate basis for all the varieties. You cannot go for individual varieties. If you want to go individual varieties, we have to use this parameter. Either economic surplus approach, how much reduction in cost, how much increase in productivity. What is the elasticity of price of supply? What is the elasticity of demand for price? Based on that, we work out the consumer surplus, producer surplus, and then that. But here, either you go by crop wise, or you cannot go deeper because you cannot disaggregate. So many one scientist working in one can do it. I think one thesis at IRA we did it that way. So we classified it, divided it each varieties, each crop, and then work out how much research we do. Then stop. Stop, you consider what are the money we spent today. That money will not absorb same year for research. You take 10% of that will be used in the first year, then 10% in second year, third year, and fourth year. Then just like you work out the cost of tractor, how to work out the cost of tractor? Yeah, through depreciation also, right? So what is the depreciated value is the cost. Similarly, in the research investment, the depreciated value, that is why I say stock. The stock may be a moving average of 5 years, maybe 7 years, maybe 10 years. Then you keep track. So we build up a series, first series of the research stocks and extension stocks built by Professor Dhyana Jha in 1966 with eminence. That is the first paper published in Indian University of Economics on the returns to investment research. Then in 85, we build up a series on research investment by collecting the data from the publications made by the government of India on investment on research. By visiting the Vidhan Sabha library, we collected manually the data and we built this series, and then we classify it to the livestock sector, fishery sectors, and that is very good. Then in 85, 86, then 1992, the Suresh and Alka, they built the series of this. They updated our series. Then after 2005, we updated that series. It might be in my computer. The returns investment series. And thereafter, no one has updated. So that's why.
So that series we can use it.
That's right. You can trace that. It's a
Bring your computer here and find it.
that. So they you use it. No. So this is a very simple procedure, and I given few literature.
It's there in the folder. I've shared everything.
Yeah, I can show you.
So can you share your Excel sheet?
Yes, everything is I've put in the computer. The whole folder is there for this.
Let's show.
This one.
Yeah. Okay, this is the this is the all chapter in the policy paper 25. Okay, you read them, and there Ramesh and myself will work on this, and this is it. Another good lecture is investment on research. Okay, public investment in agriculture research and extension. Right. And this is article published in so you can,
European Association.
yeah, European Association.
Journal of Development.
Yeah. So myself and Josie and but
She knows.
Shino. Okay. And so this will give you again some feeling how to classify the research investment by sectors. Then in another article, this one. So here we analyze by districts, Indo-Gangetic plain. In district, all the crops we are taking into account. And then we computed the total factor productivity. We divide the district into the, based on productivity, whether they are stagnating or whether there is a negative growth, a high growth, and medium growth, and so on. So this article will also give a feeling how to do the macro analysis by district, and then we can classify which are the backward districts based on technology, which are the forward districts, and which need the first priority, which need the second priority. Then how they, if you plot them by district, you can know how the changes have been taking place. It's a very interesting article. You can read that. Okay. And then there is a series of references over there, and so I think this important article. So here I try to explain which are the crops. So those are interested. This is just a flavor of TFP, and then each how they.
This complete folder is in that TFP.
And then as the time will pass, we will also come on that. So this is the one small lecture on this. Now the questions from online, anyone who has a question?
No. Any participant would like to raise their query or any questions to
Yeah.
the
Anything mind come in mind, don't bother. Only it looks very simple, and it is very simple also. We also written a program for estimating the total factor productivity in which SPSS. Under SPSS, I think that program is also you can share that. Right. So you know how each step we are doing, right? And you can quickly run the data using the cost of cultivation data. Most likely, once you start doing, you use the cost of cultivation data of one crop. There you get entire input and output. Then you compute the TFP and at least and then and you compare. If you don't apply the chain method, what number comes? If you apply the chain method, what number comes? So that is why I say you apply the chain method.
Sir, what about the interpretation of the total factor productivity? Like in your Excel sheet, last total factor productivity is from 2 point something around last figure. So how we can interpret this thing?
We say that it is a growth, right?
Total factor productivity
Yeah.
growth. Yes.
Your output growth is 3%. TFP is contributing 2%. It means 66% contribution of TFP and 33% contribution of input. If TFP growth is 0.6% and rice growth is 4%, so you know what is the share of TFP in total output. So just the box which I explained.
Last time.
Yeah. What we are doing, we say this is my production, okay? And then I say my production is increasing like this. The production always keeps increasing, no? in the initial year, we are just using land and labor. So inputs used very low. And this was the contribution of it. Then as the time moved, population increased, we like to produce more. Then what happened? We started using more inputs. This is all inputs, and this is it here. Then as you move further, we started using this, all inputs and this here. And if we go further, our contribution of TFP is this, and this is the contribution of inputs. So what does this mean? It means as we move further, we want to increase the production. If we increase the production, the contribution of TFP is declining. It means what? The cost of production is increasing. Farmers are demanding higher price. Otherwise, their income is low. Here, the income is high, but production was low. But they are using high production to meet the food security, and therefore, so now question comes: why not what kind of policy we must have so that our part must be like this? If you want to do this is our production, and I want this. I want that my input should not change, but my out TFP, then I have to increase TFP contribution. And this can be done by developing a new variety, hybrids, methodology, and just like don't go for flood irrigation, go by drip irrigation, go by spin irrigation, go for different better varieties, better urea coated fertilizer, better combination timing, and so. So our effort. So here agriculture is not sustainable because you are producing with high cost. Here you are producing, your cost of production is decline. Right? So this is the sustainable system of agriculture. This is the non-sustainable system of agriculture if we don't invest enough on agriculture and action. So if you work out, if you say this is 100, here share is 40%, here 30%, here 20%. In this case, share is 60%, 40%, 20%, 5%, and then stage will come, will be negative. It will be negative. It means whatever the money being spent on inputs, even output is not able to match. When output is not able to match the input expenditure, people say, what I cultivate, I am at loss. That is why farmers say nowadays that I am not able to recover the cost of inputs. Right? It means the contribution of TFP is very limited or no. And that is why they demand higher prices. Once we give the higher price, the cost of consumer increase. The cost of living standard increase, and then consumer demand more DA, more money to sustain. And that is why we say that you go for investment on research. Yeah. So our production must be knowledge based. Then only we can sustain the agriculture. So in the afternoon lecture also, we try to cover some concept. It will be a general kind of lecture, and many things will be inbuilt into a 1 month's life, for which we have to I'll give some literature. Any question from Okay, let's as time pass. Yeah, they can repeat this question, this session question in the next.
Sure. Okay, on that note, let us conclude this session and we'll resume at 3 o'clock in the afternoon. Also, I would like to request all the participants to mention the cell number whenever they are asking queries from the Excel sheet for the convenience of our speaker. With this, please have a big round of applause to Dr. Sugi and Dr. Kumar. On behalf of everybody here, I would like to tell that we too aspire to have such conceptual command at some day in the future. Thank you very much. Thank you very much.
No, I'm here. If any questions are there specifically, research can discuss. If they are doing their research work, any part of any area, either water, fisheries, law, lifestyle.